So what is the DL system of nomenclature of isomer? It is developed by the Fischer and Rosenelp in 1900 and it is used mainly for the applying the stereochemistry for carbohydrates and amino acid. Okay, so to name the complex amino acids and carbohydrates in Fissure projection, the carbonyl group, that is aldehyde group or ketone group or carboxylic group, is placed on the top and CH2OH is placed on the bottom. The D symbol is used when OH or NH2 points to the right and when L is used when OH or NH2 points to the left. Okay, understood? The DL system of nomenclature can't indicate which enantiomer is levorotatory or which enantiomer is dextrorotatory, but it says only the compound stereochemistry that the enantiomer is levorotatory or dextrorotatory of glyceraldehyde. Okay, so absolute configuration is introduced by Kohn, Egold and Prelog, that is called as CIP rules. Okay, so before discussing the CIP rule, we should know the Fischer projection. So what is the Fischer projection? Fischer projection is the representation of tetrahedral carbon atom as a two-dimensional structure on paper. To construct the Fischer projection, first the molecule is arranged with its horizontal bond to its chiral center, projecting above the plane of the page, and vertical bond projecting behind the plane of the page. Okay, and the most important functional group is placed on the top and the main chain of the molecule is vertical. Okay, then what is the spatial formula? Spatial formula means all the four groups which are attached to the chiral carbon and their relative position in space. Okay, understood? Then what are the conformers? So conformers means what? The shape of the molecule is due to the rotation of one or more single bonds. Examples of these are eclipsed and staggered conformation. Okay, so these are the examples of ethane. So in eclipsed conformation, the CH flagpole at C1 is exactly overlap with the CH flagpole at C2. Okay, so that is the eclipsed conformation. In staggered conformation, the CH flagpole at C1 is about 60° dihedral, so that it will be between two CH flagpole of the at the C2. Okay, so that is the staggered conformation. Okay, understood? Let us see RS system of nomenclature of isomer. So there are two different stereoisomers for a molecule that has a center of chirality. Absolute configuration is expressed in terms of R and S configuration. Okay, so R is given to the isomer if sequence is left to right, and R stand for rectus, which is a Latin word means that right. Okay, and S is given to the isomer if the sequence is right to left. Okay, and S stand for sinister, that is the Latin word and which means that left. Okay, so the priority sequence is decided by the sequence rule. Atoms are directly attached to the chiral center carbon are arranged in the decreasing atomic number. Okay, so for this sequence there will be the atomic number of bromine is greater than chlorine and atomic number of chlorine is greater than fluorine and atomic number of fluorine is greater than hydrogen. Okay, so if the sequence is clockwise, then the configuration is R. If the sequence is anti-clockwise, then the configuration is S. Okay, understood? Next example. So in this example, the sequence is anti-clockwise, means the atomic number of the bromine is greater than atomic number of chlorine and it is greater than atomic number of hydroxy group, okay, and it is greater than hydrogen. So the sequence is anti-clockwise, hence this is the configuration is S. And in this example, the atomic number of bromine is greater than atomic number of chlorine, and atomic number of chlorine is greater than deuterium and then hydrogen. So this sequence is also anti-clockwise, hence the configuration is S. Okay. Next example, 2-bromo-butane. So in this example, the atomic number of bromine is greater than atomic number of ethyl group, and ethyl group, the atomic number of ethyl group is greater than methyl group. So this sequence is clockwise, hence the configuration is R. Okay, understood? Let's see how to assign the configuration RNS configuration from a Fischer projection. So Fischer projection are very helpful in to assign RNS configuration, especially in compounds more than one chiral center. So there are three steps which have to follow. First step is the assign the priorities to four different groups which are attached to chiral center. Okay, so they are given the priorities as per their decreasing atomic number. So accordingly, bromine get first, and chlorine second, aldehyde third, and CH2S fourth. Okay, second step is the lowest priority group. If it is in the vertical position, then the observed configuration is the actual configuration. Okay, here is the configuration is clockwise turn, hence it is a R configuration. Okay, then if the lowest priority group is in the horizontal position, then the observed configuration changes, and it will changes from R to S, R, S to R. Okay, so here is the configuration turns is clockwise. Okay, so this configuration is R, but is as the lowest priority group is in the horizontal position, hence the it changes from R to S configuration. Okay, understood? Thank you.